Hello children, I am Lalit sir. Today we will understand three topics of physics: Kirchhoff's laws, Wheatstone bridge and Gauss's law in simple language. First, let's understand Kirchhoff's laws. These laws help in the accurate analysis of current and voltage in any electric circuit.
Watch this junction carefully. Current is flowing into this point through one wire and splitting into two different paths. Notice that no current is lost at the junction. Watch this junction. Current enters from one side and leaves through the other branches. Current entering equals current leaving. This is Kirchhoff's first law, also called the current law.
Now the second rule is Kirchhoff's voltage law, KVL. The sum of all voltages in any closed loop is zero. Let's see how this applied to our circuit.
According to KVL, the total breaks down. A 12-volt battery has 7 and 5-volt drops. 12 minus 7 minus 5 equals 0. अब देखते हैं किरचॉफ्स लॉज का एक महत्वपूर्ण उपयोग, व्हीटस्टोन ब्रिज. Wheatstone bridge.
This circuit has four resistances P, Q, R and S. A galvanometer is placed in the middle and a battery to power the circuit.
Now in this device, the galvanometer tells us whether a current is flowing between the two junctions. Watch the current carefully. It divides into two paths and reaches the opposite side of the bridge. The galvanometer constantly compares both sides. If both sides of the bridge are perfectly balanced, no current flows through the galvanometer. This is called the balanced condition. In the balanced condition, the ratio of P to Q becomes exactly equal to the ratio of R to S. This is the fundamental principle of the Wheatstone bridge. Once this equation is satisfied, the unknown resistance S can be calculated accurately using the known values of P, Q and R. Let's verify it with a simple example. Keep the same bridge, substitute the known values into the equation and calculate the unknown resistance step by step. Now you know how the Wheatstone bridge works. Remember one key point: zero deflection in the galvanometer always means the bridge is perfectly balanced. Today we are going to understand Gauss's law using just one charge and one Gaussian surface. By the end of this lesson, you will understand the entire concept. Focus on this positive point charge at the center. Notice that the electric field lines are spreading uniformly outward in all directions. These field lines represent the direction of the electric field. Now, without changing the charge or the field lines around it, this transparent sphere is called the Gaussian surface. It helps us calculate the total electric flux. Electric field lines pass through the Gaussian surface from inside to outside. This creates electric flux. This process is essential. Electric flux simply tells us how much electric field passes through this closed surface. More field lines and more flux. As long as the charge remains inside this Gaussian surface, the total electric flux depends only on this enclosed charge. Now watch the animation carefully. As this charge moves outside the transparent Gaussian surface, every electric field line entering that's why the net electric flux becomes zero. Now let's connect this observation to the law. Gauss's law states that the total electric flux through any closed surface depends only on the charge enclosed inside. Let's summarize the entire concept. If the charge is inside the Gaussian surface, the net electric flux is non-zero. If the charge is outside, Gauss's law for solving numerical problems. Watch this transparent sphere. It is called a Gaussian surface, an imaginary closed surface used to calculate electric flux. The net electric flux depends on that enclosed charge. If the charge is outside, the net electric flux is zero. I hope you enjoyed this lesson. If this video helped you, don't forget to like, share and subscribe to our channel.